Start recording. There we go. Huh? We're good? Okay. Last day we looked at cationic hydrolysis. Tell me what you know about cationic hydrolysis. Very rare. Okay. That's true. That should take you to your next point. I'm not going to let them all fall on you today, Elliot. I'm just going to make everybody else answer.
Only NH4 plus.
Only NH4 plus. Fe3 plus. Yes?
The other
the hexaaqua ones. Al3 plus. And Cr3 plus. Now, how could it be easy to remember these? Well, I don't actually know, but I came up with a little mnemonic device, and that is feel creepy. Yes? Feel creepy. So if you have ammonium or you have one of feel creepy, then guess what? You have cationic hydrolysis. Anything else we know about cationic hydrolysis? It always produces acidic solution, yes. Okay. So, that being said, we've got those 4 things. Does it make sense? You would think maybe that anionic hydrolysis always produces basic solution, but it's not true. Why not? Because some anions are amphiprotic. Okay, so we can say that anionic hydrolysis produces, this is page 37, it usually produces basic solution. However, your amphiprotic ions can produce acidic or basic solution. So let's take a look at our anions. Is a solution of KF acidic, basic, or neutral? So in order to figure this out, what do you want to do with your salt? How do you know that's a salt? It's made of 2 ions. And there's no OH minus. Yes? If it was OH minus, it would be a base. Okay, so if we have a salt, we're always going to say, oh, do either of the ions hydrolyze? So we need to first do the dissociation. What do we get from the dissociation of KF? K plus and F minus. Does K plus hydrolyze? No, why not? It would make KH2 plus. And it is also not NH4 plus nor feel creepy, okay? Okay, does F minus hydrolyze? We get HF and OH negative. Look at the acid that is formed, HF. Is it strong or is it weak? It is weak. So therefore, that equilibrium can or cannot be set up. It can. So hydrolysis does occur. We're on page 37. So what is produced in the hydrolysis? H3O plus or hydroxide? Hydroxide. So OH minus is produced. The solution is basic. And remember, anionic hydrolysis is usually basic. So assuming that the cation does not hydrolyze, which most of the time it does not, you look for the conjugate acid of the anion. And if it is weak, hydrolysis does occur and the solution will be basic. If the conjugate acid of the anion is strong, hydrolysis does not occur and the solution will be neutral. That's assuming we don't have the cation hydrolyzing. NaCN. Acidic, basic, or neutral? Could you tell me right away without writing all the steps? Tell your partner what you think.
Because okay, well, because it's already positively charged. Or like the conjugate acid. Like odor, they fell and started to like, why would it want to take we're just like absorbing the protons.
Yeah.
If I did manage to make any plus, would the hydrogen stay outside of the Na or would it go into the Na and like chill inside? Why am I asking that question? That wasn't making. It's even telling you not to happen. It doesn't. The word itself, it's like
It just doesn't. Nah. Nah.
Don't do that.
Don't do it. Nah.
It's like, now what do you do? Well, you're making it clearer, maybe. I don't know what to do. I don't know. No, you're right.
So how do you write a hydrolysis reaction? What do you react the ion with? If you're doing a hydrolysis reaction, you take the ion plus water. Who would be the products? HCN plus OH minus. What acid is formed? HCN. Is that acid strong or weak? Weak. Therefore, does anionic hydrolysis occur or not occur? Yes, it does occur. So we are now looking over on, we're going to cross that out because we're not looking if it does not occur. If it does occur, which ion is produced? OH minus. Therefore, the solution will be basic. Are we good? We scroll on. Is a solution of CaBr2 acidic, basic, or neutral?
Yes.
Is it acidic, basic, or neutral? Yes. That's an answer I get from my grade 9s. No, I seriously do sometimes. They're like, is it this or this? Yes.
Yeah. Hey, they're not wrong.
Let's vote real quick. We're going to vote for acidic, basic, neutral. What is happening to this side of the classroom? Nobody here voted except for these two. Okay, acidic, basic, neutral. And yes, it's okay if you just look at everybody else. But why is it neutral? Why is it neutral? Why is it neutral? Why is it neutral?
Oh, because hydrochloric acid is a strong acid.
HBr is a strong acid. So we got Br minus, we got Ca2 plus. What the heck would Ca2 plus H2O give you? It's not NH4 or feel creepy.
Doesn't matter.
So no. Whoa, crazy line. Who's the acid formed? HBr. Is it strong or is it weak? It is strong. Therefore, does that reaction go or not go? It does not go. It does not occur. So we can say we're not looking if anionic hydrolysis does not occur. If anionic hydrolysis does not occur, the solution will be neutral as long as the cation is also not producing anything. Please do this one on your own. You don't, yes.
To get full marks on a question like this, what do you have to?
So if you were doing multiple choice, you can just be like, ah, and just give your answer because you know. Yeah? If you were doing it for a written response and it said justify your answer showing the reactions, I would probably write the dissociation and then the hydrolysis. I would probably not do the cation. I would just probably say the cation does not hydrolyze. Okay? So what I'll do here is what I'm going to do is I'm going to write the work that you would need to show for this question in a written response. Yes?
Great, basic. Oh my God. Wow. Bro.
So that is what I would write if it were me. Okay. So I would say, look, here are my ions.
That makes a lot of sense.
Yeah.
Like, I just ask you after.
Okay. So are we good? All right. Common error alert. I'm hoping that you guys are never going to do this. Many students get excited when they see something like this and they're like, oh, look, I took my F- ion and what did I make? I made a weak acid, therefore my solution is acidic.
Oh no.
Oh no. Oh no. That is so wrong. Okay? We have made OH minus, so our solution is basic. Now, what's the deal? We did make a weak acid, but we also made a base. And that base is as strong a weak base as you can get in water. Remember the leveling effect? OH minus is the strongest base that can exist in water. Okay?
That's crazy, dude.
So you made a weak acid and you also made the strongest base that can exist in water. So is it going to be basic? Yes, it is. Now, the fact of the matter is that weak acid there, is it dissociated in the products? HF, is it dissociated? Or is it together? It's together. So is there any H plus off of it in the products? No. And acids aren't acidy unless they're giving away their protons, right? If they're sitting there in their acid form, they're not actually being very acidic. So let's take a look at this. We have NH4 plus water. NH4 plus is one of our cations that can hydrolyze. What just happened?
We're making hydrolysis the strongest.
Yes, we're making hydrolysis, which is the strongest weak acid that can exist in water.
Yeah, it's like the exam now. That can get on another path. Like, we're gonna get to specialize in you go. I was more than by you're now in setting the county members. And yeah, well, it's good.
Okay, so yes, we're making a base, but the key thing is that you're making H3O plus. If you make H or H3O plus, you are making an acidic solution. Yes?
Like the hydrolyze and
Oh, that is coming up. That is coming up. Amphiprotic ions. We're going to start with amphiprotic ions. Okay, it'll be the same sort of procedure though, and then we'll move on to both of them. Okay? So, amphiprotic ions have to have an H, and they also have to have a negative charge. So if our salt is NaHCO3, Will the sodium hydrolyze?
No.
No. Why will it not hydrolyze?
Because it's not one of the ones that does.
It's not one of the ones that does. It's not ammonium or feel creepy. Okay? However, HCO3 minus can do things. It can, because it has the negative charge, accept a proton. Okay, so let's watch it accept a proton. Here comes the proton. So now we have H2CO3, and the water has lost a proton, so we have OH minus. And if that was the only thing that happened, what kind of solution would we have? Basic. However, guess what HCO3 also has? It also has, not only does it have a negative charge, but it also has an H. And if it has an H, it can donate a proton. Yes? So instead of the H going from water to bicarbonate, now the H is going to go from bicarbonate to water. Okay? And now what have we made? We have made hydronium. And if that was the only thing it did, this would be an acidic solution. But some of the bicarbonates do the first reaction, and some of them do the second reaction. But if it's not exactly 50-50, then you're going to have either more hydroxide or more hydronium produced. Yes? And it is not, I can't think of a situation where it will be 50-50. There might be an acid out there that does that, but normally one of these reactions occurs more than the other. So is HCO3 better as acting as an acid, or is it better at acting as a base? How can you tell? And look, I've left you some space here at the bottom of the page. I would like you to figure that out, please. And prove it using calculations. Try it.
Therefore, we must be better at it. Right? It must be a better base.
And prove it using calculations. I want you to think about it. If you're stuck, if you don't know where to start, call me over.
That's it. Oh, you took my things, bro. I knew that. Sir, first stage real life.
Yeah. Also strong for face. Weakest acid.
We are
Okay, so where are you going to start? You're going to say, I have HCO3 acting as an acid here. I have
Like 40 minutes of 2 times speed. So like, a video. This is Jeremy.
Well, maybe you're not using it for that.
What one do you
It's basic. HCO and salt.
HCO3 is 5.6 times 10.
What?
5.6 times 10 to the negative.
If you're stuck, you're going to look at your acid base table and you're going to say, here I have HCO3 acting as an acid. Here I have HCO3 acting as a base. Yes. Can I just shh?
Can you just scroll so I can see the wording that you used for the for how it's supposed to write it? No, I think it's on a different slide.
That one?
Yep, and then just scroll up. Now you use specific like wording for the radio nice one. Nothing is on the refrigerator. Yeah, it's definitely great.
Oh, yeah, that is a typo. It should be 0.102, not 1202.
Oh,
Yeah. If you use the other one, it's okay.
it's okay.
Just pick one and go with it. I can work around it.
Then I can-
Okay, cool. Thank you.
Yeah.
Okay, hush. The blue is HCO3 as a base. What kind of strength, if you're just doing this by inspection, what is the relative strength of the base? It's the blue one. Is it a strongish weak base? Is it a weakish weak base? Or is it a middling weak base?
Middle.
It is a middling weak base. Do you see the blue line is kind of in the middle of the chart? Okay. Now our acid is the yellow line. Is that a strong weak acid, a weak weak acid, or a middling weak acid? It's a weak weak acid because if we go to our acids, we can see that the weakest ones are at the bottom. Yes? The strongest weak acids are at the top. The opposite is true of bases. The weakest bases are at the top, and the strongest bases are at the bottom. Yes? So if you are asked on a multiple choice question, you don't need to do any calculations. You can just look at it and say, ooh, it's a middling weak base, it's a weak weak acid, so it must be better at being a base. But if you're given this question on a written response, chances are they will want you to do some calculations. What number tells you the strength of the acid? Ka tells you the strength of the acid. What number tells you the strength of the base? Kb. So we can go here and we can say the Ka of HCO3 is, and we just look that one up, 5.6 times 10 to the negative 11. But we also need to find the Kb of HCO3 minus. How many of you have calculated the Kb of HCO3 minus? 5 of you. The rest of you need to right now calculate the Kb of HCO3 minus. This is going to be on your quiz on Tuesday, doing this kind of calculation. So if you've not yet done it, do it now. And if you've forgotten how, what's up? Yeah. Yes. 1 times 10 to the negative 14.
Sorry.
Hi.
Hi, this was slightly different problem.
Yep.
But same kind of concept.
Yep.
This question, I think it's wrong because
Okay, it could be.
the like see how it's like Li2H2?
Uh-huh.
Either the Li needs to have 1 or
Okay.
the H2 needs to have 1. And because you can solve it in 2 separate ways.
Yeah. Okay.
You know what I
Do you have your answer key?
No, but I have this.
Okay, no, but I'm just asking because if the answer key, if this is the thing undergoing hydrolysis, then we'll know which one I actually meant.
Okay, cool. Yeah, I'll check.
Yeah.
Example, there's no example. Hey, I'll just be right on. Let's see, it's obviously. Did you get KB as 2.3 times 10 to the minus 8?
Yes.
Okay, and then you would make a statement. If this was a written response, you would say KB is what? Greater than Ka. Therefore, the solution will be basic. Is good?
Yes.
Okay. You get to try this one on your own. The only thing is that I made a boo-boo. There should be no 2 Beside the Li, it should just be Li. Okay? Yes. I'll be right there. Okay. Okay. Okay, so we got X. Goes to. Yeah. Now, is that the only thing that can happen? Yeah.
So it's like a line.
Yeah. Yeah. Yes.
So like a line doesn't do but then that one.
And there's actually.
Oh.
Because I'm a dummy. Yes.
Can like give away the proton.
Folks, make sure you don't have a 2 beside the Li.
So you have to do both.
No, the KA or HTC.
12.7 times 10 to the negative 5.
What about the KA of the conjugate acid?
7.1 times 10 to the negative 5. I think.
7.1 times 10 to the negative 4.
That's
Neutral, right? No charge.
And
No worries, we have one of those.
Very sure.
I don't know.
Yes. I would just state that. Yes. To be honest with you, probably all you have to do is write the Ka and the Kb. Yeah?
I did it. Yeah. Oh, that's fun.
So that should be your final answer. Yes? Is that what you got? Predominant reaction producing hydronium? Because remember, always go back to the beginning and say, what is the question asking me for? I almost answered the solution will be acidic. You can see I did that. And then I was like, hang on, what did the question ask me? It didn't ask me if the solution would be acidic. It asked me to write the predominant reaction. So there's the predominant reaction. Okay? Other ways to compare the strength of acid or base, if it's multiple choice, you can actually approximate, like if they're both kind of middling, you know, if you're like, oh, it's in the middle-ish and the other one's in the middle-ish, and you don't want to just eyeball it, you can approximate using only the powers of 10. And you'll probably get pretty close. You can say, here I have Kb of HCO3. I have 10 to the negative 14 divided by 4.3 times 10 to the negative 7. If I just take the 10 to the negative 14 over the 10 to the negative 7, we get 10 to the negative 7, which is greater than the Ka, which is 10 to the negative 11. Is good? Okay. Or you can just eyeball it like we were talking about before. Whoa, what happened here? That was crazy. Okay, page 43. Could you guys solve this one? Will a solution of NH4CN be acidic, basic, or neutral? See if you can solve that. Try it. Call me over if you get stuck.
The procedure just, oh my god. Periodic said that thing. What about HCI? 4.9. Who's on the street for me? Is it part of the UC though? Like,
Yes,
If I say the sleep is just sitting on the
that is fine. That is fine. Is that what you guys got? Ka 5.6 times 10 to the negative 10 for NH4 plus. Did I do it wrong? That's a happy face. Okay. Sorry about that. Yeah, that was just me being stupid. Do you see how we're reviewing KB stuff though? And that review for KB will be good for your quiz on KB on Tuesday. And guess what? Let's go calculate. Let's go calculate on our next page, on page 45. Page 45. You could be asked to actually do the calculation. So if there's no hydrolysis, you don't actually have to do any calculation. So no hydrolysis, no calculation necessary. pH is just 7. Yes?
Are we ever going to have to deal with amphiprotic ions?
No. 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 You'll never be given anything too complicated, okay? I don't remember even being given anything that complicated in university. Maybe I was, but I don't remember it. Cationic hydrolysis. So the cation will be a weak acid. You're going to use rice and Ka. Anionic hydrolysis. It's going to be a weak base. You'll use rice and Kb because you will not be given a calculate pH for an amphiprotic. Does that make sense? You'll just be, if it's amphiprotic, you'll just be asked to decide, is it predominantly acidic or is it predominantly basic? Otherwise, you would have to do 2 rice tables and compare the H and the OH, and nobody wants to mark a question that's 10 marks long. Yes? So, if you are calculating the pH, you will not be given amphiprotic anions. You will also not be given both a cation that hydrolyzes and an anion that hydrolyzes, because otherwise, again, you would be doing 2 rice tables, right? And nobody wants that. That's just crazy talk. You will not be given amphiprotic anions when asked to calculate pH. Is good? You will not be given a cation and an anion that both hydrolyze when asked to calculate pH. Oh, look at this. Actually, it's in the note. I don't know why I wrote it down. It's in the note. Note, you will not be asked to calculate a specific pH containing amphiprotic ion, nor a salt that will undergo both cationic and anionic hydrolysis. Ding. Okay. What is the pH of the following salts if the concentration is 1 molar? MgI2. This one's easy. Mg does not hydrolyze. I does not hydrolyze because HI is a strong acid. Therefore, the pH is 7. Did you need to do a calculation? No. CrClO4. Does Cr hydrolyze? Yes, it is part of feel creepy. Cr. Feel creepy. Ammonium or feel creepy. And either on the AP exam you will be given this, or if it's the regular test, you will be given, you still have your data booklet, yes? So you are going to look in your data booklet and you will find this reaction. So let's go look on the data booklet and see if we can find that reaction. Remember, you want to look for the really big names, right? If you're looking for FeAl or Cr, those are your hexaaqua iron, your hexaaqua aluminum, and your hexaaqua chromium. The names are ginormous, so you can look and you can say, oh, here's a big name. Look at that. It's longer than everything else. Here's a big name. It's longer than everything else. Here's another big name. It is longer than everything else. And I can pick the one that has to do with chromium. When chromium goes into water, and I know you were away last day, okay? 6 waters stick their lone pairs into the empty d orbitals, okay? They just associate themselves with it. This is what we call a complex ion, and it provides us with a source of hydrogen ions. Because normally chromium doesn't have any hydrogen ions, so it could not normally act as an acid. But the moment you stick some water on there, now you have hydrogen ions. Okay, so one of those hydrogen ions can come off, leaving 5 waters and 1 hydroxide. But you don't need to be able to remember that reaction. I'm sure if you need it on AP, they will give it to you. And if you need it on the regular test, it is right here. Oakley dokley? So for all of these, the concentration of the salt is 1 molar. And if the concentration of ClO4 is 1 molar, then the concentration of Cr3 plus is what? 1 molar, which means the concentration of our complexed ion, the hexaaquochromium, is also 1 molar. Yes? It reacts with water. It will give away a proton. If you forget, you can always look on your table. How much of the base form and the H3O plus is present at the beginning? 0. Always 0. Everything is 1 to 1 to 1. So we have plus X, and minus X. That gives us hexaaquochromium at 1.0 minus X. But we are going to assume that the X is insignificant so that we don't get a quadratic. Is good? Okay. So now we have X times X is X squared over 1.0, and the Ka is 1.5 times 10 to the negative 4. Where did I find that value? That's on the acid table. Solve for X. You get 0.01225. And you take your pH as the negative log of H3O plus, negative log of thing, 1.91. Is good? Okay. What is the pH of this salt if the concentration is 1 molar? KC6H5COO. Does K hydrolyze? No, K does not hydrolyze. Does C6H5COO hydrolyze? Yes, that is the benzoate anion. Will the benzoate ion accept a proton or donate a proton? Accept. Yes, you had a question.
Why 0.5?
Where? Where?
On the equilibrium to the right table.
Oh, that's because I just can't write. 1.0. There we go. Did you guys catch that? Have you corrected the error that I am now highlighting in yellow?
Yes.
And circling in red?
Yes.
If you have not yet corrected the arrow that I have highlighted in yellow and am now circling in red, please do so now.
I think I need a third color.
We need a third color? Okay, let's use some blue.
Oh, now.
Whoa. And now it's green and blue. That's what you need to fix. So if you've not fixed it, this is what this is how I teach my grade 9s all the time. Honest to God, it's quite funny. So here's the thing you need to realize. You have produced hydroxide. If you have produced hydroxide, will you be using Ka or will you be using Kb? You will be using Kb. And if you need the Kb, how do you find Kb? Kb equals Kw over Ka of the conjugate acid, benzoic acid, conjugate acid. Okay, blah, 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 blah. There's our Kb. Yay, we did that calculation. We assume the X is insignificant, so we get a nice straightforward calculation. And then you take your POH. Don't forget, you can go from OH to POH to pH, or you can go from OH to concentration of H plus to pH. You should be very fluent in all of those. Summary, cationic hydrolysis will occur if the cation is feel creepy or NH4. Anionic hydrolysis will occur if the conjugate acid of the anion is weak. Cationic always produces an acidic solution, so use rice and Ka. In a calculate the pH question, anionic hydrolysis will produce a basic solution, although amphiprotic ones under other circumstances that you won't get here can produce acidic. Yes?
For the can we just write it like that, or it's just the one H2O, or do we need to say
Oh, 6. Thank you. Did you guys catch this fix? We need a 6 down there, okay? Do not, if you're asked to calculate the pH of a salt, try to react the salt with water. Exactly. Exactly. Do you know how often I see this though? And then people start writing like just random formulas over on the right-hand side. They're just making stuff up. And I'm like, no, you must separate the ions first. In fact, when I first wrote this, this did not say interrobang. You guys know that's an interrobang. Oh, it was not an interrobang. It actually said, but then I thought I shouldn't have that in a published book. Okay? So I was like, no. Okay, we can't do that. Interrobang. However, it's tidier if you use the net ionic, okay? Okay. So I think, have we hit the end? Okay, we've hit the end of what I'm teaching for this little section here. I am in the process of, I'm almost finished. 5.4 and 5.5 and 5.6 are actually also almost done. So tomorrow is going to be a work class. All right, on 5.1, 5.2, 5.3. Quiz on that on Tuesday. That way, if you have any questions, you can come and ask me on Monday. Hi.
Look. Okay.
So
Look, yes,
cation is positive.
yeah.
And then add you plus, right? And then add starts with A and so does acidic.
Acidic.
Yeah.
Nice.
And then anion is
Oh, no.
subtract.
Basic.
And then you have
B for base. I love it. Oh my
Yeah.
God. That's gorgeous. I need to write that down. Here, I'm just gonna take.
Yeah.
I'm just gonna take a little picture of it because writing it down sounds like it'll take too long.
May I please go buy my lunch?
You may go buy your lunch.
I was showing cation is positive. And when you plus, you add stuff together. And A add stuff with A and so does acidic, right? And then anion is negative. And then when you subtract stuff, subtract has B and that's basic.
Hello. Oh. Okay, so for this one, we've used 2 sig figs here, 2 sig figs here. I just haven't rounded it yet because I don't like rounding too early. So I've thrown in a whole bunch, okay? And so it'll be 2 sig figs at the end. So this 9.10 has 2 sig figs. Yeah. Cool.
Wait.